Hello, Fiveable. This is Shane coming at you with the AP Stats session. Today we're going to be covering sampling distributions for proportions. We'll be covering sampling distributions in general, but also focusing on proportions. My name is Shane Durkin. I'm going to be with you all year for stats, and follow my Instagram, Stats with Shane. It's not really updated yet, but I am putting together an outline. Just been a little lazy on posting content and figuring out what's the best way to actually post it. Because when I do it with my phone, it's a little wonky. So I'm seeing if I can do it with my computer. But I'll be with you all year long, helping you with your AP Stats class and helping you get a 5 on the AP exam. So we're going to dive into a little bit of what it is that we do and what we're going to be covering. So this week we're covering sampling distribution for proportions. Next week it'll be sampling distributions for means. The following week we'll be covering confidence intervals, just the basics. As always with me, you're going to get exam tips, FRQs, multiple choice, calculator tips, and much, much more. All right. As always, please tell your friends about this. The more people we get on here live, the better it is, because you get to ask me questions. Before I was working for Fiveable and before I was a full-time teacher, I was doing SAT, ACT prep and going to people's houses for one-on-one tutoring. That is so pricey. So with Fiveable, you get access to me live if you're here asking me questions for a lot less than what you would get with me in person. You can always send questions to me via email, or we'll find another way if you can do it in our chat, and I can help you out with your homework or anything else that you need. All right, so here's a little bit of a look at our agenda for today. We're going to be covering what is a sampling distribution, making sure we know the difference between a parameter and a statistic. We're going to talk about 3 important things when talking about sampling distributions: unbiased estimator, bias, variability. Then we're going to dive into the specifics for sampling distribution for proportions. We're going to look at an applet, so a little example. We're going to look at the shape center spread of a sampling distribution. Talk a little bit about the 10% condition, what happens when we increase our sample size, and then I have a couple practice problems for us. All right, so here's kind of a basic introduction to sampling distribution. This idea of a sampling distribution is when we want to know information about a population, but we can't do a census, we take samples. However, each sample may vary. We call that sampling variation. So to help with this, we make a sampling distribution. And to kind of help you out with this idea, this is how I introduce it to my students. I have this big bucket of airsoft BBs with red and white BBs. Now, if I asked you, what is the proportion of white BBs in this population, right? All these BBs are my population. You could count all the different BBs and find the true proportion of white BBs. But that would be really difficult, right? So instead, what you would want to do, turn this down a little bit, we want to take samples. So I grab this, I take a sample, and I count, okay, how many white BBs are there? Now, because sampling variation may occur, a sample distribution will take that into account. So I'll take multiple samples to get a better idea of what the true proportion of white BBs are. So that's how I introduce it to my students. Definitely good idea to introduce it to your students or help you out that way. All right, let's dive into a little bit more. So what is a sampling distribution? Well, get rid of that. All right, sorry. Little technical difficulties. Let's pull that back up. There we go. Little technical difficulties. We'll be back up and running in a minute. Interesting. This happened last week too. Not sure why. There we go. Okay. Hello, Dean. How you doing? Are you a teacher? All right, well, we'll dive into it. Dean, feel free to pop any questions in there. Tell me a little about yourself so I can kind of gear this towards you as well. Well, what is a sampling distribution? So if we took every one of the possible sample sizes of any particular sample size that we want, we'll call it N, from a population, calculated the sample proportion for each, graphed all those values, we'd have a sampling distribution. Awesome. Where are you coming from, Dean? Great. And what year teacher are you for stats? First, second, third, veteran? How many years have you been teaching stats? Oh, I remember that very well. This is year 4, so please ask me any questions. Also, if you want some resources, please let me know. So the way I introduce sampling distribution to my students, you kind of came in at the end of it, is I use a bunch of BBs. So I get a certain proportion of red and white BBs, put it in here and let them know, hey, what's the proportion of white BBs? Now, usually they'll make a guess, and I'll say there's only one way to know for sure, and that's if we count all these, right? But that's really impractical. So what we do is we do a sampling distribution to help us figure that out. So a sampling distribution is if we took every single size sample, every single possible sample of size N, and graphed them, we would get a sampling distribution. And the sampling distribution of a statistic is the distribution of values taken by the statistic in all possible sample sizes of the same size from the same population. Now that's tough to do, right? It's tough to get every single sample of size N. So instead, we just simulate the process over and over again until we have a good idea of what the distribution looks like. So here's essentially what we're doing. So from our population, we're taking a whole bunch of samples. And remember, this is where students kind of struggle. They have to use the correct language when writing on the AP exam. So when we take a sample and calculate the proportion, we always want to use P hat versus P. Because remember, when we take a sample, we're getting a sample proportion. And each sample has a different proportion because of sampling variation. So the way I tell my students is statistics come from samples, so S and S, and we use X bar, and whoop, that should be P hat. Let me go back to that. So that should be P hat, not mu. Let's change that. And then parameters come from populations, and we use mu and P. Plug that in right there. And this is going to go up here. So what I tell my students, statistics have hats and bars, parameters don't. And remember, parameters are describing populations. Statistics are describing samples. In sampling distribution, we can have two kinds of sampling distributions. We can have proportions and we can have means. This is a great applet, Dean, that I use with my students. If you want to take a screenshot, send me an email. I can definitely send this to you. But if you go to it, it'll look like this. Great way to show them what sampling distribution is. So we're going to hit begin. And we have this population, whatever it is. It's normal. And we can see the mean right here is 16. standard deviation of 5. So what a sampling distribution does is if you pull a sample, so 1, 2, 3, 4, 5, then you generate a statistic. Now remember, statistics come from samples. So out of these 5, when I sampled these 5 things, I averaged them, and I got this right here. And a sampling distribution is when we do that over and over and over again. So we keep taking samples of size 5 and then graphing that statistic. Take another sample of size 5, calculate the statistic, and graph it. And we do this over and over and over again. And as you can see, the more we do it, the more normal it becomes, and B, the center of our sampling distribution, which is down here, becomes the center of our population distribution. So let me do that one more time. Let me clear this. Okay. So here's the mean of my population. Here's the standard deviation. If I were to take a sample, let's change it to maybe, let's keep it at 5. Take 100,000. Take a look at the mean of my new sampling distribution. It's the same. And if you notice, my standard deviation has decreased. We'll get into the specifics on why the standard deviation decreases later on in the presentation. But for right now, just know that the average of your sampling distribution, or the center of your sampling distribution, if done correctly, and we'll get into bias and unbiased estimators again in a little bit, going to be the same as your population. And that's true for any type of distribution. So what I like about this applet is you can actually change this to be a skewed distribution. And so students can see, okay, if I create a sampling distribution from a skewed distribution, what is it going to look like? Well, watch. So I'll pull 5, I'll pull 5, pull 5, pull 5, pull 100,000 or 10,000, another 10,000, and you're going to see the distribution becomes somewhat normal. Also, it's centered at about the same center as your population distribution. So it doesn't matter if it's skewed, uniform, normal. If you take enough samples, your sampling distribution will also be normal. The other thing I like to show with my students is what happens if let's go back to our normal distribution. I took a sample of size 5. If I increase that sample size, let's say to 25, what's going to happen to my distribution? Hopefully what they notice is your distribution has a smaller spread. Again, we'll get into how that happens in a couple slides, but this is a great way to show kids when you increase your sample size of a sampling distribution, you're decreasing your spread. And again, there's a formula that I'll show you in a minute. So I'll come back to that a little bit later, but for right now, let's get back into our presentation. And again, feel free to ask me any questions. If you're like, hey, I need a resource on that, do you have like a quiz on that, a PowerPoint, a lesson that you use, just pop it up in there and I'll be sure to send it your way. Okay, so we talked a little bit about unbiased estimator in the applet. Let me talk a little bit about it more right now. So a statistic used to estimate a parameter, remember statistic comes from a sample, to estimate a parameter, which comes from a population, so we use statistics to estimate parameters, is unbiased if the average of its sampling distribution is equal to the true value of the parameter being estimated. So let's go back to my BBs. So if the true parameter here, if I take a bunch of samples and I get the average of that distribution equal to the true parameter here, then I have an unbiased estimator, meaning the way I sampled is unbiased and it'll get me the true parameter. In order to create a better sampling distribution, and here's where we kind of got to with the applet, you increase your sample size. The larger samples are more likely to produce an estimate close to the true value of the parameter. And essentially, when you increase your sample size, you're just limiting the ability for outliers to have a big effect, right? If I'm trying to get the true average height of a Skyline student, which is where I teach, and I sample 5 kids, it's possible I could get 5 really tall kids, versus if I sample 20, it's very unlikely that I'll get 20 tall kids because my sample size has increased. So increasing your sample size gives you a much better predictor of the true parameter. Bias. So what is exactly bias? So bias means that our aim is off and we consistently miss the bullseye in the same direction. Our sample values do not center on the population value. For example, if I was, again, trying to get the true population height of a Skyline student, and my bias was only athletic teams, I only sampled athletic teams, it's probably going to give me something a little bit different than what the true proportion is. So my sampling method is bias. And then we have something called variability. And when we have high variability, that means that the repeated shots are scattered all over. So samples don't give similar results, meaning some of my samples are really high, some of my samples are really low. Which textbook are you using, Dean? This is the one I get from my textbook. It has a great image of the difference between bias and variability. So if you look at that top left one, it has high bias because every time I'm sampling, I'm missing the true proportion or the true parameter, which would be in the center. But it has low variability. Awesome. That's a great textbook. That's the one I use. This image should look familiar if you're using that textbook. Which version are you in? My district is broke. We have the 3rd edition. And I just got sent the 6th edition, which is really, really nice, but I don't think we can afford it right now. Awesome, awesome. So this is a good image to show. Oh, wow, great. You quite lucky. That's a good textbook. So this is the image I show my students just to kind of get the idea of what it might look like to have a biased or have high variability when it comes to sampling for a sampling distribution. So if you look at A, you're going to see high bias and low variability, essentially meaning, hey, we're off all the time when it comes to our samples, but low variability, meaning our samples are in the same area most of the time. B is low biased and high variability. C, high bias, high variability. Again, variability is, do you consistently hit the same spot every time, or are you scattered all over the place? And the ideal is right in the middle, where you have no bias, meaning every time you sample, you get a statistic that is true to the parameter, and low variability, meaning your samples don't vary far away from each other. All right, so what are like the key parts to describing a sampling distribution? And on the AP exam, students may be asked to describe a sampling distribution, in which case they will have to describe center, shape, and spread. So once again, on the AP exam, your students might have to describe center, shape, or spread on a free response question. And so the way they can talk about center is using average, right? And so if P hat is an unbiased estimator of P, here's how you get the average. You take your 1 over your sample size multiplied by your sample size times P. And essentially, that's just going to leave you with P. Then your spread. So they're going to want to talk about spread. Spread is going to be similar to the standard deviation of a binomial setting, right? That n times p times 1 minus p is the way you find spread for a binomial distribution. Same way, except we multiply it by 1 over your sample size. And so if you look at the end formula, you can see as we increase that sample size right there, we're going to get a smaller number, meaning our spread's going to decrease. So that's kind of how I show kids, hey, this is how we decrease our sample size, or our spread, I'm sorry. is we increase our sample size. And so what I'll do is if there's an example problem, I'll take whatever sample size they have, we'll plug in the numbers, we will get a standard deviation. Then I'll say, okay, what would happen if we increased our sample size 2 times? So instead of using the original sample size, we'll insert a different sample size in there, and they'll see, oh, I saw my standard deviation shrink. Ideally, that will lead to the conversation around why does our spread shrink if our sample size increases? And I found that my students are pretty intuitive when we have that conversation. Have you already covered sampling distribution? Let me know in the chat. So there is a normal condition that needs to be met before we do any sort of normal calculations with a sampling distribution. What do you mean by that? So just like we can do normal calculations with a population distribution, we can do the same thing with the sampling distribution if the normal condition is met. So if I get a whole bunch of samples and I plot them on a distribution, that again is a sampling distribution. Let's say you want to know, awesome, okay. Do you know how they did? Normal conditions are definitely key when it comes to the AP exam, because any sort of, yeah, it takes a minute. Any sort of problem, especially FRQ, that they're going to need to do on sampling distribution, they're going to have to check conditions. So I'm sure whoever taught it before you hopefully talked to you about students needing to provide evidence that conditions have been met in order to run any sort of test, interval, or calculations. So one of the key ones for sampling distribution is the 10% condition, or the normal condition, I should say, which essentially means your sample size times the probability, or I'm sorry, the proportion is greater than or equal to 10, and your sample size times 1 minus your P is greater than or equal to 10. So those are the normal calculations that need to be satisfied in order, I'm sorry, those are the conditions that need to be satisfied in order for normal calculations to be done. So this is the image that I really like to show my students, just again to show them what a sampling distribution is all about. So we take a simple random sample of a certain size. After we get that sample, that generates a P hat. And again, I really like to go back to these beads. I'm in California, so I was just able to order these online. I think Florida, if you go on Amazon, you can do the same thing. But essentially what I'll do is I'll take this and I'll say, okay, and these bead counters are great if you get them online. They're pretty cheap. Again, I use Amazon, but I'm pretty sure you can get it at Walmart, Target, any of those places. So we take a sample, we plot the proportion of white beads on the board with our sample size, and we do that. I have every student come and do that, and so we create a class distribution. One of the things that have helped me throughout the years teaching stats is just creating a whole bunch of posters and visuals every unit. That way, kids can look around and see the different posters, and they're reminded of the certain key topics of each unit. And again, the best way to learn stats is to do it. So we do that over and over again. That gets the idea of this first part right here. And then I let them know, hey, every single part inside here is no longer a single data point. It's now a statistic. Again, really stressing that we're finding statistics from samples to estimate a parameter from a population. So really emphasizing that, because again, if they go on the AP exam and they use the wrong notation, they're going to get marked down. So we have our standard deviation here. Again, we talk a little bit about, okay, what happens if I increase the size of this bead counter to, double? Instead of 20, it's now 40. And again, they kind of see, oh, I see the standard deviation is going to shrink. And then the mean of all these samples is going to be the true mean. All right, so let's get to some practice problems, particularly a free response, just so that we know what is going to be asked of them on the AP exam. And just to give you an idea, Dean, of how I do my tests here. Yes, absolutely. And that's something that they can state, right? Is they can state, hey, we can assume that there are more than 4,000 children in the United States or 4,000 children in the state. Just make sure on the AP exam they say that. So they need to say, they need to show their work. So they need to show n times p greater than or equal to 10, plug in the n, plug in the p, and make sure that they state, hey, we believe that there are more than 4,000 students in a certain state. That's very true. So one question I have my students do when it comes to the AP exam, let me see if I can minimize this. Let's just go ahead and exit that out. Okay. Is the 2008 free response question B. And just to give you an idea of how I do tests in my class, I've gone to trainings just about every year for the past 4 years through the company NIMSY, and met a lot of great teachers who kind of showed me the best way to do tests. And for me, I do multiple choice one day, and then the next day I do free response, and I pull actual free response questions from old AP exams. I change them up a little bit just so students can't memorize the exact word for word language, but I change them up a little bit and just use the same concepts. And the reason I do that is so that we can grade it like an actual AP exam. I do have to change my grading a little bit just to make sure that it's more reflective of school versus the AP exam. Because on the AP exam, you can about to get 50% and get a 3 on the exam. So that's just how I do tests. Always looking for new ways and new ideas. So if you have a new idea, just pop it in the chat. But this is the 2008 free response question form B. And the idea or the intent behind this question is to assess students' ability to recognize an unbiased estimator. So what is unbiased when taking a sampling distribution, and explain why something is unbiased or why something is biased. And then compare two estimators to see what is their center and what is their variability like. Have you done this one with your students? And I'll go ahead and read this one. So 4 different statistics have been proposed as estimators for a population parameter. Again, while I'm reading this in class, I'm making an emphasis on 4 different statistics have been proposed as estimators to a population parameter. To investigate the behavior of the estimators, 500 random samples are selected from a known population, and each statistic is calculated from each sample. The true value of the population parameter is 75. All right, so that's key. We know what the population parameter is. It's 75. So if it's a legit, unbiased estimator, then these sampling distributions should be centered around the center. And I should say, I just said sampling distribution, but remember, it's not a sampling distribution until you take multiple, or until you take every single sample of size n. The graphs below show the distribution of values for each statistic. So we have statistic A, B, C, and D. So A asks, which of the statistics appear to be unbiased estimators of the population parameter? And how can you tell? And so this right here is getting at which one of these distribution is centered at 75. Because remember, if it's an unbiased estimator, when we do our sampling distribution, the center of that will also be the center of our sampling distribution, or of our population parameter. So if we look at statistic A, it looks like it's centered about 75. So we would say A. B does not look centered. So B looks centered at about maybe 85. So we would say this is not an unbiased estimator because there's something pulling it away from the true parameter. C looks like the center is, even though it's kind of funky. And D also would be the center is at 75. Again, they look kind of funky, but the center is at 75. So those are unbiased estimators. And we know that they're unbiased estimators because they want us to say, how can you tell? So we know that because for each of these, the center is about 75. Now I'm cutting it a little bit short here, but in an actual AP response, you would want to say, we can tell that statistic A, C, and D are unbiased estimators because the fact that the mean of the estimated sampling distribution for each of these statistics is about 75, which is the value of the true parameter. So A, C, and D is the center. The center is about 75, which is the true center of our population. So I like this because it gets to what is an unbiased estimator. And sometimes students kind of skip over that part. Next, which of these statistics, A or B, would be a better estimator of the population parameter? Explain your choice. So, which one, A or B, would be a better estimator of the population parameter? Again, this is getting towards bias. So we want to go with A. Why do we want to go with A? A would be a better choice because it appears to be unbiased. Although the variability of the two are similar. All right, so we have about the same variability. A would produce an estimate that tends to be closer to the true population. So once again, the reason we choose A is because it's centered around the true center. So A seems to be centered at 75, which is the true center of our population. B isn't. B is centered somewhere a little different. Then we dive into C. So C asks, which statistic, C or D, would be a better estimator of the population parameter? So now we're looking at these two. We're looking at C. We're looking at D. We want to know which one would be a better estimator of the population parameter. This one's all about getting variability down. So statistic C would appear to be a better choice because it has a smaller variability, right? So although both are centered at 75, C produces estimates that tend to be closer to the parameter. And this is where I would also go back to that image of the bullseye and let them know, hey, both are hitting the target, or both the center is 75, but this one is more scattered. So if we were to draw it out, right, this one might be more like this, whereas this one, high variability. But if I took the average, it's still going to be 75, or in this case, the bullseye. If I took the average here, it's still going to be 75, even though not a lot were on 75, but the variability is smaller. Great one for one to do in class, especially right after you talk about variability and unbiased estimators. For you, Dean, I would recommend when you're going over your review, this might be a good one to pull out and do as a review question. I also have a couple quizzes I like to give my students. And you probably have seen these, Dean, because they do come from the textbook. This is from the 4th edition, though. Again, my students don't have the 6th edition. We're using the 4th edition. If this is not something that looks familiar to you, Dean, please let me know in the chat, and I can definitely send you this so you can use it in your classroom, maybe again as like a review. Got lots of different activities, quizzes, tests from the past 4 years of teaching AP Stats. So feel free to either put in the chat, I'll send you my email, and we can kind of connect over email to make sure you get the resources that you need to help your kids get better on the AP exam. Does this look familiar? Really good way to practice, like, okay, what is that formula again for mean, for proportions? So it says, according to the 2000 US Census, 80%. I like to have my kids underline what we're looking at. So 80% of Americans over the age of 25 have earned a high school diploma. Now, again, I like to have them underline it and then decide, is this a statistic or is this a parameter? 80% of Americans. So this is going to be a parameter because it's a population. And so we want to use P to represent proportion. All right, so this is proportion. This is a population. So we use P. Again, it's like 10 seconds of our time to make sure students are making a connection about what is a parameter, what is a population, is this a proportion, or is this a statistic or a mean, and then what is our notation that we use. Awesome, Dean. Yeah, I will shoot you my email and we can connect and I can send you a lot of resources, especially as it comes to the later chapters with like confidence intervals, which is what you're getting into, and hypothesis testing after that. Yeah, so we'll connect after this. Suppose we take a random sample of 120, okay, we're thinking statistic here, and record the proportion p hat of individuals in our sample that have a high school diploma. What are the mean and standard deviations of our sampling distribution for p hat? So at this moment, I'm like, okay, let's go back in our notes. When we have the average of a sampling distribution, and again, I'm really stressing them to write it using this notation. Readers on the AP exam, and this is actually going to be the first year I actually get to go to Kansas City and do a reading with them. But readers are looking for the correct notation. If you put something like this, they're going to mark you down. So you want to put the average of our p hat sampling distribution, our proportion sampling distribution for proportions. Narrating this to my students to make sure that they know what this means, right? Because it can be a little intimidating if they just walk in and see this. Now, don't overthink it. It's the average of our sampling distribution for proportions. And that equals 1 divided by n times p, which is essentially just p. Well, what's p? That was 0.8. Oh, let me do this. Sorry about that. Or I'm sorry, what is that? That have a high school diploma. What is the standard deviation? So our standard deviation of p hat is equal to the square root of p times 1 minus p divided by n. Oh, awesome. Yeah, that's what I hear. Everyone tells me that the reading is the best training. So very, very excited. They got you teaching statistics. They're throwing you for a little bit of a loop. So again, we're just practicing that formula over and over again. So we have this square root. Again, just making sure they know what each of these parts mean. P, probability of success. 1 minus P is failure. Or, I'm sorry, in this case, having a high school diploma, not having a high school diploma. Then dividing that by our sample size, which is 120. And where's my TI? Oh, hold on one second. Not sure where I put that TI, but you get the idea. I'm hitting my time, so I do want to take this opportunity to make sure that we exchange some information. So I'm going to type in personal email here, or my let's do personal email. So go ahead and send me an email, Dean, and I'll get a whole bunch of materials to you, and we can just continue working on getting the materials and tests you need to make sure the rest of your year is successful, as well as just answering any questions back and forth. One of my favorite parts about just being a teacher is getting to meet teachers from all over and just sharing ideas, right? Like the best way to teach is to pick apart what people have done in the past that have been successful and kind of put your own twist on it. So again, shoot me an email. I'll get you quizzes, tests, lesson plans, some just quick things I use. AP Stat Medic is a really good website. Again, that's AP Stat Medic. There's a great video series called Against All Odds that I would highly recommend you use. It does a great job of breaking down different concepts and showing them cool graphics for each of them. So shoot me an email. I'll get you a whole bunch of resources. In the meantime, I'll be back next week. We'll be talking a little bit about sampling distribution for means, and then we'll get into confidence intervals the following week. The good thing is that you're way ahead of schedule when it comes to your pacing. So you're on the right track. You should have about 3 weeks to review. And yeah, your kids will be doing well. All right, Dean. Well, if you have any other questions, please let me know. In the meantime, I'll see you next week. And feel free to tell your students about this. Yeah, and then they can, hear it from both ends. See you next week.